Next, we're going to
example of how to use linear equation to predict what happened in the future.
this first example here. We talk about farmers market. The increasing popularity of farmers markets in the United States can be modeled by this linear equation, where T represents the number of years after year 2000, and F here represents the number of farmers market. So we'll try to graph the equation. Okay, the first thing to do. Now, this is the equation over here. This is the number year after year 2000. This is the number of farmers market right here. Okay. To graph this equation, first take a look, is this a linear equation? Yes, you see the exponent on the right over here are 1 and it's not in the denominator. And this could be written in the standard form of the linear equation. So yes, indeed, it is a linear equation. So the graph of it is going to be a straight line. So let's try to pick 2 points and maybe a third point as a check. So I'm going to choose T to be 0, 2, and 5. For T equal to 0, which is the year 2000, 0 year after year 2000. Okay, so substitute 0 into T, we got 2,728. So the number of farmer market over here will be 2,728, okay, in year 2000. In year 2 over here, which is, what about when T equal to 2, which is 2 years after year 2000. So we're going to substitute 2 over here for T, and we'll do a similar calculation, and it's going to turn out to be this number. And for year 2005, which is 5 years after 2000, then the number of farmer market will be this. Okay. So to graph this, we plug in those points. This is corresponding to year 2000, and here year 2002, year 2005, this is 3 points right here. And notice that over here you see that this one here, because from 0 to 2000, this is a big distance right here. Sometimes you can actually do this. So that means you can break this coordinate. You can break this. So you can do this to say, okay, you skip another number over here. Now
This is 2,500.
this is 3,000, etc. Okay. So you plug in those 3 points, and then you graph this line over here. Okay. Okay, so this is a graph. Okay, that's a graph for that equation. Notice that the T here can only be positive. We're talking about, oh, notice that T here, we only consider positive T. So we only consider the time after year 2000. So this is the graph of that equation. Now, B, suppose the trend continues. Use the graph to estimate the number of farmers market in the year 2015. Well, in year 2015, that will corresponding to T equal to what number? T is equal to 15, right? So over here, we're going to locate 15. That's 15 years after year 2000. So we locate 15 here, and we go up and hit the graph. And we look to the side and see the number of farmer market is about 6,750. So we predict that in year 2015, the number of farmer market will be about 6,750. So if the trend continues, then we can actually predict what's happening in the future. Okay, right. So that was the first example. Okay, next example, depreciation. Example 6, depreciation. A copy machine that was purchased for $6,750 is expected to depreciate according to the straight line depreciation equation, where Y is the value of the copier after X years of use. When will the copy have no value? So the strategy here, to find when the copy have no value, we substitute 0 for Y in this equation. Remember the Y over here, this Y over here, and it stands for the, what does it stand for? The Y is the value of the copier. Okay, so Y is the value of the copy over here. Okay, so when that has no value, so that means Y is equal to 0. Okay, so 0 value. Okay, so we want to find out what is this X over here. So that will give you this, that will give you Y equal to 0. Okay, So they gave you this straight line depreciation model. Okay. Now you just need to use this model to find out when this copier have no value. Okay. So we substitute, have no value means y equals 0. We substitute y to be 0. So y to be 0. And then we're trying to solve for x over here. We want to find out what's the corresponding year. Okay. So solve this equation. We subtract 6,750 on both sides. Okay. Now, in this step, we're going to divide, undo this multiplication, we divide. Divide by negative 950, okay, on both sides. So we got x is about this number. If I only keep one decimal place, so that's about 7.1. Remember, for word problem, the last step is to write a complete sentence. So you write the sentence here. The copier will have no value after it has been in use for approximately 7.1 years. So that will answer the question. Now to graph this equation, now since we only consider positive time, so we only have this x here, the number year here to be positive number. So when x equal to 0, so that means when the copier is brand new, the value of that is, we substitute 0 into x, we got y to be 6,750. So that is a brand new value of this copier. Okay, so you see this number over here corresponding to the brand new value of the copier. Okay. Okay, now, and then when y equals 0, which means when the copier have no value, then we find out that the years, the corresponding years here is about 7.1. So put over here. So this nice segment over here is for this equation when the time x is between 0 and 7.1. Okay. So this x-intercept over here actually corresponding to the number of years that the copier has no value. Y-intercept corresponding to the brand new value of the copier or the purchase price of the copier. Okay. All right, so this is the end of our lesson. I'll see you guys next time.